Welcome back to our system design series. Today we are going to explore caching strategies and how to choose the right one for your system. Caching is one of the easiest and the most effective ways to boost system performance, reducing response times, and offloading database. But choosing the right caching strategy can make all the difference in how well your system performs. So, if you don't know what is caching, let's just try to make a quick example so you could understand what is caching and how it works. So, let's say that we have a client and the client tried to send a requests to our application. Let's assume we have an e-commerce application. Okay, and the application will have will send read or write requests to the database. So whenever the client wants to read a specific products, it will send a request to the app. The app will send a query to the database. If the product is available in the database will send it back to the app, and the app will send it back to the client. It's pretty simple and it works well and it's also scalable. However, if you want to ask ourselves a question, is there a way to improve this process first to make it faster, also to make it more scalable, also to reduce the load on the database? This where cache comes into play. So we could add cache, and the cache is in memory storage. So it serves data way more faster than the normal database. So the cache will store the frequently accessed data. For example, if the client asking for this product a lot, it will be stored in the cache for a specific amount of time. And whenever the client try to get the product, and instead of the app get it from the database, it will try to get it from the cache, and the cache will serve it directly. And since the cache is in memory storage, it will serve it way more faster. So caching is essentially the process of temporarily storing copies of the data in high-speed storage layers, so it can be retrieved faster. The idea is simple. Instead of going to the main database for every request, a cache stores frequently accessed data, reducing latency and load on the database. However, the effectiveness of caching depends largely on the strategy you choose, which in turn depends on your data access patterns. Whether your system is read heavy or write heavy or mix of both. So let's start first by talking about some strategies, and let's start with the cache aside. This is an example of cache aside. The cache aside strategy is one of the most commonly used caching approaches. In this strategy, the cache sits on side on the database of the database and its application that is responsible for managing both the cache and the database. Let's understand how it works. First, the application checks the cache to see if the data is available. So let's say that if the client try to reach and know, try to read a specific product, first the application will try to send the request to the cache. Sorry for that. To the cache, okay? If the data is found, if we have a cache hit, the data is read and it should be returned to the client from the application. So the cache will send it back and it will be returned to the client. If the data is not found, which is we call a cache miss, the application then queries the database and retrieves the data, returns it to the client, and store it then in the cache. So future read results could get cache hit and not cache miss. So this is how it works. The use cases in the cache aside is best for read-heavy workloads where the same data is frequently accessed, such as user profile information or product catalogs. The pros and cons of this one. The pros is the system can still operate if the cache fails, as it can directly query database. It also allows the cached data model to differ from the database model. And the cons of this one strategy is that cache inconsistencies can occur if data is updated in the database and not in the cache. We can use like time to live is often used to manage state data, which may not work well if freshness is critical. The second thing we had a read through that the read through cache. So let's try to give it an example here. Okay, let's create a new one. So we'll have our application, and the application will sets the requests to the cache, and the cache will send the request to the GB. So as you can see here, the read through cache, the cache sits between the application and the DB. So in the read through cache strategy, the cache, as I said before, the cache sits in line with database and the application. When the cache misses, it loads the missing data from the database, populates the cache, and then returns it to the applications. It's pretty simple. Like if the application needs to read something, and it will be served directly from the cache. If the cache doesn't have it, it will try to read it from the database, and the database will send it back, and it will send it back to the application. It's pretty simple. This strategy is useful for read-heavy scenarios where the same data is frequently requested, such as news article or popular posts. Unlike cache aside, read-through cache offloads the responsibility of managing the cache from the application to the cache itself, which can simplify application logic. The cons of this one, on a cache miss, the application incurs latency of loading data into the cache, which can mediate by warming the cache beforehand. So the only problem that we can have some sort of latency, because if we have no data in the cache, we will make additional requests to the database. Number three, we have write through cache. The write through cache looks exactly like that. This exactly. It's quite similar, but let's see how it works. This is like, oh, let's just take it down. Okay, let's talk about the write through cache. So in a write through cache, data is written to the cache and then to the database. The cache sits in line within the database, ensuring consistency between both of them. It's also in line as the previous one. The application, but here what it's happened, it's that the cache works on the write. So basically, the application writes data to the cache, and then the cache updates it to the database. And this guarantees that both the cache and database always have the same values. So it's a pretty useful in write through cache works well when paired with read through cache. They are paired with each other as well, as they provide both read performance and data consistency guarantees. The pros of this one, consistency is guaranteed since the data is always written to both the cache and the database, and the cons as well, as we said before. This there are is like there is a performance cost due to the double write operation, like because we write the data to the cache and database, that could introduce some sort of latency. The next thing we have the write around cache. The write around cache is pretty simple. The write around cache strategy is the data is written directly to the database without initial being to the cache. So basically, it will be quite different. So the data will be directly written to the database. Oh, let me delete this as well. The data will be written directly to the database without being initially written to the cache. Only when the data is read does it get stored in the cache. So it's only work on reads. This approach is suitable for data that is written infrequently but read occasionally, such as logs, for example, or archive information. The pros, it avoids populating the cache with data that may not be read again, reducing cache memory usage. The cons of this one, this strategy can lead to cache misses for recent written data, resulting in slower reads until the cache is populated. Um, Next, I guess we have the write back. The write back as well, it looks, the cache is also in line with the database and the application. Let's call application, and we have the cache, but it has a slightly different approach on how it works. So in the write back cache strategy, the application writes to the cache first. Okay, so the application will send the request to the cache first, which acknowledge the write operations immediately, and the cache then synchronously writes the data to the database at later time. So if the application try to create a write request to a new product, and it will the cache once the cache obtain it, it will acknowledge it and send it back, send the response back. That means the process is successful, and asynchronously it will try to send the request to the database to store this data. The write back caching is best suited for write heavy workloads such as analytics or log systems where frequently writes are needed but data consistency can tolerate slightly delays. Um, the pros of this one, it provides faster write performance since the data is acknowledged after writing the cache, making it good choice for high throughput systems. It also tolerates short-term database outages. If the cache, the problem is that if the cache fails before syncing with the database, data may be permanently lost. This is one of the biggest problem. Okay, let's talk about how to choose the right strategy. So we did talk about four different strategies. So I would say if your system is read heavy and data freshness is not critical, use cache aside. Okay. Let's make it quite bold. So if you need guaranteed data consistency, write through cache will be a good fit for that. Through, I don't know if I'm writing right. Yeah, I guess I'm writing right. Okay. For write heavy systems where performance is a key, write back is a good choice for you. Okay. So each caching strategy comes with trade-offs, and understanding the behavior of your data, whether it's mostly read, mostly written, or mixed, is crucial for selection the right approach. So in this video, we explored different caching strategy, including cache aside, read through cache, write around, and write back. Each of these strategies has its own strength and weaknesses, and choosing the right one depends on your specific use cases and goals. So if you found this video helpful, please make sure to subscribe and hit the notification bell so you'll never miss a video, and see you in future videos. I guess in the future videos we'll try to maybe talk about some strategies in details, and maybe we'll talk about some important things like the time to live, how to actually how the read through cache works in details, and etc. So that's it for this video, and see you in the future.